So
Yep.
thank you for watching the live streaming of this AIST Creative HCI Seminar. This is the fifth edition of the seminar. And so first, a bit of the logistics. This seminar will be completely online, except for us in the Tokyo University of Arts, which is provided in courtesy from Tomoya-san, the presenter of this seminar today. And we're going to use this shared seminar notes on Google Docs. So if you have a smartphone or tablets or anything, you can scan the QR code and access the Google Docs that should look like this. And on this Google Docs, this is kind of shared notes. And so feel free to write down anything that you notice interesting. And then the most important thing is you can write down the questions for each of these sections, like invited talk by Xavier, invited talk by Tomoya, invited talk by Baku. And in the end, there will be the place you can put any topics that you want to touch, you want us to touch during the panel discussion. And so essentially, you will form the panel discussion, and we really appreciate your collaboration. This event, this particular edition of the seminar is actually related to this another event. So this is kind of Japanese events. I will speak in Japanese, but 今回のセミナーはですね、実は日本バーチャルリアリティ学会アートプラスエンターテインメント研究委員会というところの、主催でやっているこのミートアップ3、アートやエンタメをテーマとした研究や作品の評価方法の共有という、セミナーがですね、今週土曜日に開催されます。でそちらと、一応、タイアップしてという形になってますので、先方の、案内にもこちらのセミナーのリンクがありますし、こちらからも先方にリンクしてます。割と興味が近い人が両方見て楽しいイベントかなと思いますので、ぜひ日本の方はですね、こちらにもご参加いただければと思います。So this seminar has been organized by these organizing teams, and there's this advisory board. Also, it's co-organized by SIGKAI Japan chapter, ACM. And today's focus is creativity support tools for artistic work. And we invited Xavier Lambein, Tomoya Matsuura, and Baku Hashimoto to give the invited talks, followed by the panel discussion. So I will give a bit of context of why we are here. Actually, in the AIST, which is my affiliation and kind of organization behind the seminar, we have discussed the future of human-computer interaction research. And we have this kind of shared vision that people will soon be surrounded by AI-enabled tools and can or forcibly need to focus on human-specific tasks, notably creative tasks. And so we really have this focus on creativity support at AIST. And when we look back the past of this creativity support tools research, well, there is a kind of long history of doing this research for several decades. Ben Schneiderman wrote this kind of notable paper back in 2007. And then these days, there is a kind of criticism that we have, develop many novel creativity support tools, which is cool. But at the same time, many of these tools have developed in research lab, and they never come out from the lab. So it's really developed out of the context of practitioners. And then there is another criticism that many of these research have been done in the weird context, Western, educated, industrialized, rich, and democratic, which is kind of biased toward tool development. And there is this kind of continuous criticisms. So as community researchers, in particular in HCI, researchers have kind of came up with the idea that we should do research in the wild, and we computer science researchers must always be careful that we are not cherry picking the activities of artists just for the sake of research. We need to go dive into the wild and help and observe what practitioners are doing, and also kind of co-develop the tools that they need. So this is kind of context. Creativity support has a long history, but it has been criticized for its in vitro approach. And there is an uprising interval approach, which is a tool development within practice. So today's talk will be provided by the cutting-edge researchers and practitioners in the field who are developing their own tools for their artistic work. And so this is the timetable. I am currently providing this kind of brief introduction of the seminar. And I think we are ready for the first invited talk by Xavier, who is the artist and programmer. So I will stop sharing the screen. And now the stage is yours.
Okay.
Yeah, thank you.
Yeah. Okay, can you see this?
Yes, perfect.
Yes? Okay, awesome. So hi, my name is Xavier. I'm an artist and programmer. I'm based in Brussels, in Belgium. My day job, I work as a software engineer, and then in my spare time, I'm a musician and I do various research projects. And so here I'm gonna be talking about the current project that I'm working on. It's called PA. It's a programmable and visual audio workstation that uses bidirectional programming as an interface for music production. And it kind of stems from some of my frustrations with using traditional tools for music production. So I already talked about this project last month at the live workshop, which was also co-organized by Jun here. And so there's going to be some overlap, but here I'm going to try and talk about slightly different things. Mostly I want to talk about my experience using this tool for myself and kind of the conclusions that I draw from it. So first, PA is, as I said, a bidirectional programming environment for music production. I want to break this down. I'll start by talking briefly about music production. So the way musicians and producers create music on the computer these days usually is with tools called digital audio workstations, or DAWs. And so they kind of look like this screenshot that I have of a tool that I've used a lot called Outdoor. So usually you have this panel in the center with the various instruments that you're using and little audio or MIDI clips that are recorded for it. And then you can move those clips around to arrange your song. And around this central panel is a large array of different tools that are used. And so basically, when you're doing music production, it's a very complex task, and it has a lot of depth. And so usually these tools have a lot of features to answer the needs of the musicians. And my personal frustration with these tools is that despite their like massive complexity and number of features, I still somewhat regularly find myself confronted with a limit. And so I'll give you a little example of something that happened to me. This is a screenshot of a compressor plugin that I use in Ardor. And so in Ardor, maybe I'm working on a track and I'm recording several different backing vocals for this track. And I want all the different vocals to have the exact same compressor on them so that they sound kind of the same. And the way that I would do this is I would like set the compressor on one track and then copy paste it on other tracks. But then if I realize that I don't like the sound of it, well, I need to essentially tweak one compressor and then copy paste it again onto the other tracks. It's a very manual process. So maybe I would like to essentially share the same settings across different plugins on different tracks. And this is not a feature that's being offered by this program. Ardor is an open source DAW, so I could download the source, change it, recompile it, maybe make a pull request to the original project to add this feature. But then I'm bound to find myself faced with another feature that I would like to have in this program, and that is missing. And so the point that I'm kind of getting at is that in most GUI applications, you have almost all features that are ad hoc. What I mean by that is that they're purposefully built by a developer into the application. And then maybe you have a few features that are emergent, as in they're like emerge from the combination of simpler parts. And because of this, a user will always be limited in what they can do because they'll be limited by those ad hoc features. And so an idea that I believe in is that complex tasks need compositionality, which is something that GUIs often lack. And so if I'm going to try and design a better DAW, I guess the first thing to do is to think about what a DAW really does if I remove those limiting GUIs that I'm talking about. And so if I really boil it down to its actual function in terms of music, a DAW is essentially just a function And so this is like a Haskell function that I wrote, but what I mean is like it's a mathematical function or a programming language function that takes as input a few like audio recording and MIDI recording, some other things, the current time, and then outputs a pair of audio samples that are going to then be heard on my loudspeakers. And then this function is evaluated like tens of thousands of times every second to produce the music that I'm working on. So this is kind of what a DAW does under the GUI. And then the GUI itself is giving me a way to specify what I want this function to do. But because this is a general purpose function, unless the GUI allows arbitrary programming, it's always going to be limited. So there's a quick solution to this. We could just write code. And this is what some people do. In live coding, people write code in a DSL that produces music. And so they write a little program. The program is evaluated, and that produces an audio output. And then editing this program live is part of the performance itself. This is great for generative and repetitive music because when you're writing a program, it's easy to generate complex patterns from simple rules. But it's not as good for more traditional music production, mostly because visual tasks are difficult to do through textual code editing. And the example that I have here is I have those little waveforms here. And usually when I'm recording vocals, I want to cut them very precisely and align them with respect to one another so that they sound really in sync, which is, I wouldn't want to do this via pure text editing. And so the idea that I'm exploring is, can we reconcile live coding and graphical DAWs? And the answer that I found is yes, through bidirectional programming. And so what is bidirectional programming? As a quick explanation, the idea is that a person is writing a program that generates an output, and then this output can be directly manipulated to change it, and changing the output is reflected back as a change into the source program, which is the bidirectional aspect of it. And the example here I have on the right side is this Sketch and Sketch program, which is a bidirectional tool for SVG drawing. Okay, and so now I'm going to give you a little demo of what it's like to use this program that I made, which is called PA. So is the video working? Yes. Okay, so on the right-hand side, I'm basically opening a normal text editor. It's the text editor that I use for my job as a programmer. And then it displays the source code, which is the definition of this function that I talked about that is evaluated repeatedly to produce music. And then let's maybe hear what it sounds like. Okay, this is yeah. And then so on the left-hand side, I have this GUI that has appeared when I open the file. And so this GUI is generated through static analysis of the source code on the right. And for example, here I have this record that I'm highlighting, which defines the drum track that I can see on the left. And so this is just the programming language definition of this track. And then I have this dollar track at the top that I'm about to highlight just in a second. And this syntax here is telling the runtime on the left, hey, I want this little bit of code here, this little bit of data, to be represented on the left and be interactive. And so if I move this clip now on the track on the left, it's going to actually update the location of the clip in the source code here. Let's see that. Okay. And then I can do the same with, for example, resizing the clip, and it'll move the endpoint of the clip in the track, in the data in the program. And then I can undo my changes and then save it, and it restores it back because it's just a text editor. I have other clips. For example, here I have a checkbox. If I click it, it toggles a Boolean. And then all these widgets are live. So if I change them as the music is playing, you can hear the change in volume. Here I'm enabling a click track that I use for recording all of this. So yeah, that kind of gives you an idea of how this works. And then I have this second demo that I want to share with you. I think I'm having some issues. Yes, I need to exit the full screen. Okay, I have the second demo that I would like to share, in which I'm going to demonstrate how I'm actually using this program myself as a musician in my practice of music production. And so everything that you can see, I've added while like working on this project, and I want to see, I want to show you how I did this by adding a new instrument, connecting it to a MIDI keyboard, and then adding a track for it, recording some clips, and then playing it back. So the first thing that I'm going to do here is I'm going to add a new instrument that I'm going to call synth, because it's a synth. And I'm going to basically do it by copying the bass instrument that I have. So my bass is located in a different file that I just opened. This is the source code for it. And so I can see that it has a couple of oscillators here and there. I have an envelope and a low pass filter. And so this sounds like a good bass, a good basis to create a new instrument. So I'm going to save it into a new file called synth. And then I'm going to rename some stuff to create this new instrument. Once this is done, I can go back to my main file and import the synth so that I can use it in my project. Then I need to restart the GUI on the left-hand side. And now that this is done, you can see that there's this little window that appeared on the left, which shows the control for this new file that I added to my project. And so you can see all the GUIs here that correspond to the interactive values in the synth. And I can change them around. So now this is decoupled from the bass. And so now that this is done, I want to actually use this synth connected to my MIDI keyboard. So the first thing I'll do is I'll instantiate the state here. And then I'm going to go down a little bit and start using this synth in my main loop that's like producing those samples that I talked about. So I'm copying the code for the bass and then replacing some things. And basically what I did here is I'm connecting the MIDI input to the instrument and adding some gain and so on. I'm also removing the code for the bass just for performance reasons. And so now I'm going to play, and I'm going to play back this, and I'm going to play on my keyboard as well, and we can hear the synth. Okay. So the next step that I want to do is I actually want to configure this synth to my liking, because right now it sounds exactly like the bass. So what I'm going to do is I'm going to play back, and then I'm going to start tuning these parameters, use a different type of waveform. I'm going to change the attack. And then I'm going to tune some other parameters like first I'm going to make it a little bit louder so that we can hear it better. Okay. And then I'm going to tune the low pass filter, adjust the frequency and everything. Now that I've done this, I think I want to add some more effects to this. So I'm going to add a new filter. I copy paste the code for the low pass filter and turn it into a high pass filter. And then once I do this, you can see that the new controls have appeared on the left. I'm going to show that in a second. So here I have the controls for the low pass, and then below it the high pass. Oh, this sounds bad. So I'm going to tune it a little bit, adjust the sound until I have something that I like. And then now that I'm happy with this, the final step that I'm going to do is I'm going to add a new track for this. So I'll return to my main file. There you go. And I'm going to, again, copy paste the code for the bass, which is here. Rename stuff from bass into synth. Remove this clip that I don't need. And save. And now I have this new synth track that's appeared on the left. And so now if I click on the record checkbox and I start playing, I can actually record stuff. Okay. And so now I have this new clip that's appeared, which contains my recording. But if I play back, I won't hear anything because it's not connected to my synth. So the last step that I'll do is I'll go back to where the synth is actually being used and connect the track that I just created to it. So that's what I do here. I save, and now if I play back, and lower the volume a little bit first. we can hear the recording that I made. Okay. So that's it for the demos. Now let's talk about this. So I hope that you saw some stuff that you found like interesting or exciting about this, but also maybe a little bit baffling. And that's what I'm going to discuss here. I'll start with the good. The good of Pi is that I think it does succeed as a proof of concept of this idea of using bidirectional programming in order to replicate the types of workflow that I can do with a traditional DAW. I've used it myself to produce a few like demo tracks like this, and it's cumbersome to use, but it works and it feels in a lot of ways like a real DAW. Another thing that I like about this is that I get all the power from programming, like textual programming languages. So I have, abstraction, composition, code reuse, and so on. But I also have all the tooling. I'm using my favorite text editor for this. I'm using Git to track changes. I can diff, I can use LLMs, and so on. And then finally, this is a very open system. Everything is within reach and editable. It's a great system to learn about sound synthesis, which I knew very little about actually before I started working on it. And so I can easily create new effects, like look at the source code of one, change them, hear the changes live, which is very different from the experience that you get developing shared libraries for DAWs, which are usually just written in C++ and precompiled. And then you have the not so good, which is usually, overall, it just boils down to the fact that PA is an early prototype. So it's kind of slow and buggy. It's missing important features. The GUI gets messy when you have too many interactive values. The code and the GUI are too disconnected. They're hard to navigate together. I'm thinking of trying to embed a text editor into it. But I think most of these are relatively low-hanging fruits. And I have a relatively clear vision of how to fix them. And then we have the bad. The first thing that I want to talk about is the boilerplate. It takes way too many steps to do simple things like add a track or an effect. And this is partially the language's fault. It could be improved with a better syntax, a better semantics, libraries, auto-completion editor macros would probably help as well. But some tasks are fundamentally non-local and they can't be automated easily. For example, as you saw, adding a MIDI track in PA, I need to add a track definition, reference the track in several places, and so on. It takes a lot of steps. If I'm using a traditional DAW, I just press a button, it creates a new track, connects it to my MIDI keyboard and to an audio output. It's seamless. PA has too much freedom and not enough structure to automate these tasks. A possible solution could be code synthesis, but it's a lot more complex, kind of out of scope of what I'm trying to do with this project. And then another big problem that I have with this is the problem of creative mode versus problem-solving mode. So when I'm using PA, I have two different modes that I'm using. I have creative mode, where I'm jamming and composing, arranging a song. And then I have problem-solving mode, when I'm editing code, fixing bugs, changing, creating effects, changing effects, and so on. And I find it difficult to navigate, alternate between the two. It's kind of like PA is a little bit too much like a programming language when I'm trying to just make some music. I don't have a clear solution to this. I think it might get better with improvements to the language and with improvements to the number of libraries and everything, so that I don't have to make everything from scratch. And maybe I'll also just get used to it. Finally, I'm going to talk a little bit about future plans for this. I'll try and go quickly. First, I'd like to improve the language and the libraries. The language is way too verbose, imperative. It's not great to use. I'm missing many useful libraries. Their APIs is not great. And in general, it turns out that it's hard to make a good DSL for music. And I know that Tomoya, you've worked on some of DSLs for music. So I'm curious to hear your thoughts about this. And then another thing that is really important that I haven't explored is users who are not me, because I'm both the creator and the only user, so my insights are limited. But also PA is still pretty buggy and hard to use. I'm not really sure when's a good moment to start sharing prototypes with other users and how to make sure that users don't get scared by a prototype that is buggy. And then another important thing that I think is paramount to the vision that I have is user-defined widgets. So currently, all the widgets that you saw are hard-coded in the runtime. But I think to truly realize the ideas in PA, I need user-defined widgets so that GUI of PAR can also be malleable and compositional, can be adapted to the needs of the user. But ideally, this would be done in the same language as the one that I use for music, which is a kind of a strange requirement. So that's also an interesting question. And that's it. I'm now open to some questions.
Yeah, thank you so much for the talk. It's really inspiring, as well as the live talk that we listened several weeks ago. We now have, well, actually many questions in Google Docs, but do you want to start? Like, do you have any particular questions? I can pick some from the list, actually. 自分の質問してもいいかな。もちろん、もちろん。
So I have one question. So I want to ask, what is the built-in or primitive function in the PAL? Like you use the synthesizer or the filter, but how is the low-level code is written in the language in the PAL?
So the language that I use for the runtime is Rust.
Yeah.
Is that the question?
I mean that can you define the very basic level of the digital signal processor, like the filter?
Yes. So the primitives that I'm using in this are just the Jack API essentially, and some API that I expose from the runtime. But then all the code for the signal processing function, the filters and everything is written in the same language.
Great.
It's my first time to hear the Jack library, but it seems like it's Jack audio connection kit, is it?
Yeah.
Okay, I see. So you're using this as kind of baseline, and then the programmer can, well, actually the user can actually build new functions based on that within your environment.
Yeah, exactly.
And then your environment is kind of full-fledged Rust programming environment, or is it somehow limited? I mean, there is a kind of domain-specific language that you're using, and then so is there a kind of chance that the user needs to go back to a kind of traditional program environment like Visual Studio Code, write down some libraries and then import it in your environment and use it? Or how expressive is?
So my ultimate goal is that this would not be necessary. And right now, all the like signal processing code that I use for this, I've written within this environment in this kind of live fashion that I showed. So all the signal processing is written in the same language, like as the one that I was showing when I was editing the code here. The only things that are like written in Rust are some more like very lower level things in the runtime, things to like kind of handle audio buffers and things like this. And also currently all the widgets are written in Rust, which, as I said, is something that I want to change. Ultimately, I want the Rust part to be as thin as possible. I'm not quite there yet, but it's getting better.
I see. Thank you. Did you have any consideration of the selection of programming paradigm used for how, like, imperative one or functional?
Yeah.
Or how did you manage?
So basically, I made choices based on mostly what I was comfortable making, because I made the compiler for this, and so at first I tried to make a functional language, but I found it difficult to make it very efficient. And since I wanted to write everything in the same language, I wanted it to be efficient enough for lower level programming. And so eventually I settled on a compiled imperative language. But I now regret that decision, actually.
Oh, really?
Yes, I think it's a bad one. And one of my goals in the future is to essentially change most of the language to be more functional, and to be to have some better forms of automatic memory management. Because this is just this language is not fun to use for music production. And if you use a real language that was made for live coding, the experience is so much better.
So probably related question is that a kind of technical question, but I see many let statements, and so it's really a kind of imperative one, right? And I think that the whole code is reevaluated every time the code is edited. And so I have a question like, if so, how do you keep the consistency of the GUI widgets on the left side while the right side is edited? I mean, if every time it's been updated, it looks a bit flashy, and it's just a technical question.
Well, this is basically just a compiler design question. Like essentially the text editor on the left is just sending little updates to the runtime. The text editor on the right is sending little updates to the runtime on the left, telling, hey, I added a character there. And so that way I can keep track of which places have changed. And so I can assign unique IDs to parts of the syntax tree and then map those onto the GUIs.
I see. So that's how you make it stable enough for edits on the code side and also the GUI widget side. Thank you.
Exactly.
I have one more question about the data type. So if you're doing the signal processing on the language, is there the distinction between the normal floating point number type and the signal type, like max or the super collider, the control and audio?
So no, right now I'm using a float 32 type for my
every
signal output.
Processor is defined like a sample by sample basis.
Yes, exactly. That's one of the things that I would like to change, though. I think overall it would be better to treat the audio signal as a stream, so that I can do efficient operations on them rather than do them sample by sample, like array operations, basically. It's one of the bottlenecks in this design.
A bit of future-looking question. Do you see any possibility that Copilot, like GitHub Copilot, can help with this composition via just source code-based composition workflow?
Yeah, I've thought about this a little bit. I'm actually a recent user of Copilot. I kind of resisted it for a long time, and I think there are two problems. No, sorry. There's one problem that I find with using Copilot for this is that there's not enough source code out there for it to be trained on. So that's a problem. But maybe long-term that could be solved. But then I do find an interesting advantage for this is that it might help with the problem that I mentioned of dealing with the boilerplate and having non-local actions. The problem is that my experience using Copilot is that oftentimes it'll spill out code that is almost correct. And so then I need to try and understand what Copilot made and then fix it, understand how to fix it and so on, which when I'm just programming, this is fine. But if I'm like in this process of creating stuff, like trying to make music, and I'm just trying to like use this program and then I have to figure out what Copilot did and fix it, I think that would be less fun.
I really like the way you say it, like less fun, because making music should be fun enough, right?
Yeah.
And it sounds like using the Copilot is more like debugging the source code rather than making new code. So it's not like making new expressions, but rather than, I mean, it's more like Copilot makes some music and you're kind of correcting it somehow, which is, I think, different from what we expect from the current DAW tools or the PAL, right? Thank you. Okay, so there is a comment that, is your goal to create DAW or PAL is to make something that is capable of all kinds of music, or considering more specific music genres?
So my goal is to be able to make the music that I make normally on DAWs. And so it would be like more traditional, like rock music, I guess, is the type of music that I make. indie rock. And so this is kind of like what I'm aiming for. But I'm aiming to be relatively general in terms of what you can do with it.
Yeah.
More specifically, I'm trying to not fall into making a product that only serves to make electronic music, because I think that would be a little bit too restrictive.
Right, I see. Thank you. Do you have any questions? Yeah,
We can talk about that later talk session. So
okay,
it's okay.
all right, of course. Can post be still bidirectional even with the use of like for statement or if statements? Like if there is a let statement that should pop up as GUI and there are for loop, and the for loop runs for 10 times, there should be 10 sliders, right? So how would you think of this kind of problem?
Well, actually, no, because basically the only thing that the system is doing is editing the syntax tree. So, you get one widget for each syntax element that has a widget.
Makes sense. Oh yeah, that should be.
I thought about doing it another way, but this way actually makes more sense when you're trying to do audio, I think.
I see. Oh yeah, that's interesting, because I have a prior experience of doing something generic GUI application development environment, and there we were trying to somehow populate the geo widgets based on a kind of runtime information, and then that will incorporate all this, for statement executed for 10 times, and then 10 sliders populated, and we kind of keep track of the stack of the runtime, and that was a bit difficult to manage. I think your choice sounds reasonable.
Yes, I think it's really a question of whether you're making a system where you're editing the runtime information or the compile time information. Here I'm editing at compile time in sense, whereas what you're describing is more changing values at runtime.
Right. Yeah. Thank you.
May I have one more question? Sure. How did you realize or represent kind of a large data type such as a web form data format in a textual programming code? Is it stored as a other file, as a wave file? Or
yes, basically yes. The wave files are stored externally. Same for the MIDI files.
Is MIDI also saved as an external file, right?
Yes. Yeah.
I see.
Yeah, sounds like kind of popular approach that. I mean, I also have an experience of using image data type and human posture data type, and these kind of data could be really large. So I just save these data as files with arbitrary file names and then refer it within the code editor. But I just hide it from the users so that they don't need to. They don't need to think of the file names. And that's a good benefits of using these graphical representations, because then people don't need to name all of these graphical things.
Yeah. Yeah, okay, it's the hardest problem in computer science, naming things.
Yeah. Okay. So thank you. I think we are running out of time for this particular talk slot. We're just going to move to Tomoya-san's talk.
Okay. I'm going to share my screen.
So thank you so much for Xavier's talk and this fruitful question and answers.
So can you see my screen? Okay, I'm going to start my presentation. So I'm Tomoya Matsuura, and today I'm going to talk with the title of Domain Specificity, Normativity, and Generality in the CSTs for Arts. And in this presentation, within the theme of creativity support tools for artistic expression, I will try to add more theoretical and historic context, partly because Xavier has just shown the real example of programmable DAW. In particular, I will use the history of sound programming environments among creativity support tools as an example of why creativity support tool or domain-specific language for expression tend to lose their flexibility and why they should not. Then I will then conclude with a brief introduction of my software, otopoiesis, I am currently developing that integrate functional programming and DAWs. So I'm going to briefly introduce famous environments for the softwares around music and programming languages, and and some of the most common and commercially popular music production software, they are called DAW, digital audio workstation softwares, including software such as Pro Tools, Cubase, Ableton Live, and Studio One, and so on. Many of these software can be considered as a simulation of the workflow derived from physical workflow, such as tape recording and editing, and like hardware sequencers and so on. And also many of these softwares can be extended by using plugins, which are either audio effects like echo, distortion, and reverberation, or instruments which are synthesizers that take note information and then output audio. On the other hand, there are also programming environments for sound, as the software for creating sound on the computer too, such as Cycling 74 Max. While visual programming environments like Max are popular, there are also many text-based languages such as SuperCollider, Sonic Pi, and Tidal Cycles, and so on. Users of sound programming languages sometimes desire to work with digital audio workstation software, but the options are not as diverse. In many cases, they use what they have made in programming language as an audio effect or synthesizer, just like any other plugin. So one famous example is Ableton Live, which allows users to create audio plugin and synthesizers with an environment called Max for Live. This is just an extension that embeds whole Max runtime itself onto Ableton Live. And there are many user-made plugins, both paid and free, made with Max for Live. As an open source example, there are also several projects that turning program made with pure data into plugin. This is another popular sound programming languages, which shares common history with Max. Recently, the plug data environment by Timothy Sean, this has a more modern GUI, has been popular. However, it remains difficult for those users to modify core functionality in terms of extending functionality through programming. For example, if you try to make polyrhythmic music with mixed beat, the workflow becomes very difficult than the usual. However, then domain-specific language like Max or Pure Data do not have the capability of abstraction, as if one were to build a DAW-like application from scratch. So basically, in music, there have been a kind of division of labor between those who compose music, those who use music programming language, and those who develop such languages. I consider that this division of labor is caused by the long-established mental model of signal processing with computer. That signal processing model is called a unit generator. Many of today's sound programming environments have inherited at their foundation the concept of unit generator, which interconnects basic signal processing units such as oscillators and filters and envelope generator and so on. This concept was born in the 1960s and was introduced starting the earliest computer music environment called Music. Using concept is introduced in Music version 3. It is important to note that at this time, GUIs like using CRT display did not yet exist. And so sound programming in this era was the process of writing actual score on the paper, writing using this graphical connection on the paper, and translating them into text format, and again translating them on the whole of punch card, and rendering the result of offline process on magnetic tape, and listening to the finished sound. So this using concept has not changed much since the 60s and remains the premise for all audio programming paradigm. For example, the Web Audio API standard, which synthesizes audio in the web browser, is practically based on unit generator concept. Many people may think that this usual model is kind of a simulation of a hardware synthesizer in which the signal flow is assembled by connecting physical patch cable. They are so-called modular synthesizer. But in fact, modular synthesizers were invented at about the same time as using concept. But anyway, there is no doubt that the idea of modular synthesizers, especially after GUI became common, such as the idea of separating low frequency control signal and signals that are actually audible fast rate signal. And these ideas have been fed back into the structure of music programming languages from modular synthesizer. And furthermore, in the 1980s, the use of hardware accelerators made real-time signal processing possible, and the hardwareization of the unit generator, it came to take precedence over the meta manipulation of the program. So after all, in any software to make sound, be it those visual programming languages or even text-based languages, we heavily rely on the visual metaphor of connecting unit generators. Mm-hmm. I will argue that this ultimately leads to a division of labor in the use of music software and the lack of space of modification by user. Because visual programming language is specialized for flowing and transforming data, however, it is really difficult to treat function or programs themselves as the data. Put another way, current Fusion-based visual programming languages can at best express only visually displayable complexity. It is not impossible to do meta-programming in Max or pure data. However, the style would be very imperative, like sending a message to application runtime to, for example, creating new objects. So Thor Magnusson, the researcher of computer music, called digital musical instrument as epistemic tool. This means that the design of a computer-based instrument and the use of it always operates sounds through symbols, which are made by someone. That fundamentally embeds the musical culture of time. More simply, compared to acoustic instrument, computer-based instrument and music creation system are more difficult to pursue alternative form of expression. There's no space to misuse. So furthermore, once the tool itself has been given a predefined vocabulary for the expression, it eventually becomes more difficult to reach outside of that vocabulary of thought. Magnusson says that this kind of negative feedback loop as creating a snapshot of musical theory, freezing musical culture in time. So domain-specific language are not so significant to ensure generality if they are viewed as a means of problem solving for the productivity. However, in the case of languages for arts or music, bringing a specific mental model or metaphor into the language spec may limit the diversity of expression eventually. So have there been any attempts at a higher level of abstraction or alternative abstraction that goes beyond mere Eugen connection? I'm going to share some projects. So Max Matthews, the creator of the unit generator concept himself, actually did not persist with the Eugen concept and continued to search for new ways to abstract sound on the computer after the 1970s. The groove system created by Matthews and Moore is a good example. This system could handle only low frequency signal up to 200 Hz though. It is considered as one of the beginning of today's reactive real-time sound programming environments like Max. However, its basic design philosophy is really different from the unit generator concept, which Matthews and Moore described as file system for time function. Note that still at this time, skeuomorphic GUIs like Macintosh did not exist in the world. Groove could record the multiple data stream from sensor, and also they have special scripting language was as the core engine, which can generate signal directly from the text or combine multiple track of recorded data and create another signal. The Matthews believes that this groove system could eventually be applied to any kind of process that deal with time, not only just the music. So what was important in the groove system was that starting from the musical application, but it still aimed to general expression of time function universally. There are several other examples of pursuits of a more general representation of time functions themselves. The most representative one is a chronic by Brand. Brand proposed a system called temporal type constructor. This is a generic representation of a time function, type of the time function, as a combination event that is some data with a timestamp, and the finite vector. This is the finite array of the data, and the infinite vector. This is actually a function that generates some data type over time. So, and composing these type constructor, you can express any kind of complex time function. But this was implemented as a library of the OCaml language, so it didn't work with real time. And maybe the most unique among today's sound programming language is the Faust. Faust is a strongly formalized functional language that expresses any signal processing by combining signal blocks with 5 types of operators, primitive operators. That is parallel and series and split, merge, and feedback. So as well as hygienic macro, which enable higher order abstraction. An important finding brought by Faust is that most signal processing can be expressed with just a basic arithmetic and delay and feedback. Signal processing in music is often not a pure function, but rather holds some internal states. Therefore, many are represented as a kind of data structure like object, which is a pair of internal state and function. But using delay and feedback, this can replace this internal state. Then the unit generator connection can be represented as a pure composition function. So the mimium language that I have been developing is based on this idea of Faust and formalize its internal representation, but it's more like based on lambda calculus. Originally, it settled on such a specification as a result of implementation, but double calculus, which had a similar idea, was proposed at the same time as I presented mimium at the conference. And I'm currently now working on defining more formal definition of these internal languages. So then I'm gonna introduce another software I'm now developing. That is, I named this otopoiesis. And the concept of this software is simply to make the data structure of DAW a bit more abstract. Usually, a DAW has a structure of multiple tracks in the project file, and eventually signal the sent from multiple tracks through the mixer. And the track may also apply effect from incoming stream, another track, but it usually holds several audio clips, or usually called regions, which contain fragments of recorded data and eventually produce a single audio stream. Then region holds recorded data along with the data of a certain length of the data and the position of a number, position of a seconds. The recorded data is usually audio file, but which can be generalized that it holds a result over some operation of a function that produces some audio. So plugins in a typical DAW either convert an array of MIDI note data into an audio, or audio effect is their function that translate audio into another audio. So why not think everything other than track as function? If you think of project, tracks, and region as function, then some of the features used in DAW can be thought as a kind of subset of a process in the execution of programming language. For example, a track preset, which insert a fixed set of plugin into track, or a project template, which insert a predetermined set of track into a project, can be thought of. This is also kind of just function. There is also a process called freeze, which is temporary render tracks that are heavy to do with the real-time calculation. It is a similar functionality called bake in the 3D CAD software. Also, the term is exactly opposite direction. But anyway, this can be viewed as a process called constant folding or partial evaluation in programming languages that evaluates the compile time constant in advance. Furthermore, if the project itself is parameterized, kind of recursive data structure can be considered that embeds the project itself as a region, which may improve the reusability of the process. And my current status of otopoiesis is the more and more early prototype that is that can generate only sine wave and applying the fade in and fade out. So I'm going to show that such a demo. So for example, this is the example of the function that translates region into another region. So these kind of the fade in and fade out for the region is usually supplied as the built-in functionality in the normal DAW, but this otopoiesis in the fade in and fade out is also written in the user code. So this is a current otopoiesis is the window, and the right side of the window, this otopoiesis still has not the textual syntax. So just a raw syntax tree is shown as a JSON format. So I translated by manually. This is a kind of pseudocode of the code syntax. So fade in and out function takes an expression that has a type of region, and then apply the fade in and out to its contents, but keeping the length is the same. So this is the small demo. I opened the project, empty project, and add some track and add some region with the sine wave generator. Sorry for the very small font. I'm now moving the region, and the position and the duration of the data in the code editor is changing. And this is now, there's no fade in and out data. Maybe there's no sound, I think, but it's okay. It's because there's only the sine wave sound. And you can see the parameter for the sine wave oscillator. And I now apply the fade in and out function to the oscillator. Then you can see that another slider showed up. This is the parameters for the fade in and out. And you can see the waveform changes. The fade is applied. And currently, the parameter for GUI is automatically grouped by the lexical scope of the function. So if you applying the effect to the region, automatically the parameter for that effect is added to the original region. This is kind of the basic structure of the application. There is a source code, and source code is compiled and generated as the value of the project. And the compiler do kind of static analysis. This is the part of extracting the parameter from the tree structure of the evaluated the value of the project. And the project is finally evaluated as a sound program and a sound, and the GUI GUI sends a value through the shared memory and changes the such as parameters such as frequency or amplitude. So this is a very basic example or the proof of concept of this software. Such affects processing on region, and in many cases in DAO is done as a kind of destructive process. If the operation on regions can be composed together as a function, including data type conversion, it should be possible to do something like this, for example. Famous for what the Beatles did, reversing recorded audio data, which was physically done back in the days. It is often done as a musical expression still today. At this time, if you want to create arbitrary melody in the end, but it sounds like reversed, you need to play and record the phrase in reverse order. For example, if there's like MIDI-like note data as a source data, the process of reversing the phrase can be reused as a function, and by reversing order of note data, and then applying the synthesizer as a function, converting it to the audio data, and then reversing the audio again. So actually, that's all. So I'm going to wrap up my presentation. So today I talked about domain-specific language for music, and how we model and abstract data of the domain is a key of the domain-specific languages. However, about the programming system for art and music, such a fundamental model may eventually cause the negative feedback of the expression diversity and normalize. In other words, the challenge in this area is to maintain the ability for users to change the core functionality of the tool. In other words, the tool's metaprogramming capabilities without losing its intuitiveness and the beginner-friendly features. As an example, very early example of such an attempt, I presented otopoiesis, a prototype of the software that considers a DAO project file as a composed function. Yes, thank you for listening.
Thank you. Well, we also have a bunch of questions, but Xavier, do you have a kind of question specific to this talk?
I don't have any questions. I'm more like, I guess, a general like remarks that I really love this approach.
Yeah.
I can see myself, because I started working on PAW a few years ago, and I can see that like if I had decided to go a little bit more in the GUI direction, I could have ended up with something much closer to this. And it looks like it's answering a lot of problems that I saw with PAW being maybe too programmable. Like it seems like a really interesting exploration of this design space.
Yeah, thank you. So let's see. So I can clearly see that there is a need for direct manipulation of sine waves. So if we want to do the fade in and out, we want to do like, drag and drop operations to customize the parameters for these functions. What do you think is, do you have any ideas on a good way to define such kind of meta GUI operations on top of this?
That is a serious problem.
So it seems like Xavier is trying to solve the problem by embedding that part as the project, right? He said he wants to make his own programming language more expressive so that the programmer can define GUI part within the code editor. But I see like, there is this two different ways of solving it. One is to have this built-in features to build customized GUI like Xavier is trying to do. And the other is to kind of have a meta level language that we are currently doing, right? We have this static analysis and then populate the GUI on the environment side. So I just thought.
Yeah, some sound programming language have their own GUI generation feature, and there have always been problems at how we grouping the UIs. For example, this is the source code of the Faust languages, and they are grouping the kind of GUIs by kind of embedding the another kind of the DSL as a level of the name of the parameters.
It's pretty much like the XPath for HTML, like specifying a specific part of the AIST or kind of program path.
Yes.
Interesting.
But I think I don't know if it's the right approach. So this is a different part of my applications, because the grouping is automatically done with the when user creates a new function. So the grouping of the parameter is tied to the not the parameter value but the function. So I think currently I'm now thinking like the adding the attribute or metadata to the function when user define function. Maybe eventually we have the two different compilers for the GUI generation or real evaluation.
Yeah, pretty much like the literate programming approach. Yeah. Thank you. Sounds very interesting. One last question. What is the ultimate goal of programmable music composition? Like improving the efficiency of composition tasks, expanding the expressibility, or enhancing portability with modules and version control systems. Probably this is kind of, what is your ultimate goal?
The one of the purpose of this project that I didn't talk today is sharing the music as a code. So if the complete language spec is defined, this project file itself becomes as a mimium of the music. And actually, there's some attempt in the MPEG standard called MPEG structured audio.
I think I heard
that is based on the C sound languages, but it never became popular. But in these days, there's a kind of format called object-based audio formats, such as Dolby Atmos. That is the very complex audio structured data audio formats that has the kind of the many sound sources and the many metadata. That is the 3D position of each sound sources. That looks like project file of the data. So, but this kind of format is it's really exciting that because the musician can express more kind of the immersive experience, compose immersive experience, but this field is prepared by someone like Dolby. So if we can make the final product of music as a code, that is a kind of my ultimate goal of this project.
Yeah, that sounds exciting. Like kind of truly open source music, which is not bound to the current technical limitations, right? So, for example, in the images, they are rasterized or vectorized, and vector images can be zoomed in for ultimate level, and then it's the same for the music, I guess.
So, if you know the compiler theory, you can write down the actual sound wave by the text format of the source code.
And then the people in the future might listen to your music
by seeing the code.
By quality. Code. Yeah, sounds like a good goal for the musicians. Thank you. Okay, so let's move on to the next talk. Yeah, thank you so much. The next talk is provided by Baku Hashimoto.
Okay. So thank you for introducing me. And I'm Baku Hashimoto, mainly worked as a motion designer, visual artist, but I recently kind of no longer doing paid works, and I'm focusing on tool development these days. So here's my short introduction of with my very long titles. And after I went to art college and dropped out from there when I was 19 years old, I have been working as a video director in the field of music video or advertisement industry. From this February, I began working as a collaborative researcher in AIST, along with Mr. Kato as a mentor, and he has helped me to verbalize what I'm doing in the context of HCI or CST. So that's why I participated in this seminar today. And okay, so here's my works, but there's only 20 minutes, so I'm gonna show you a bunch of thumbnails quickly. Okay, this is my works. And anyway, every time I make something, I always try to come up with new techniques to make, and that style or way of making became my signature known in our community. So for examples, I made a pixelation using a Google Street View, or made a stop motion by integrating VR room tracking devices with Dragonflame, which is the most popular software in the stop motion industry. And I also scripted a CAD or CNC machine to make an animation of milling process. But I gradually began feeling like why it is always so tedious to customize the feature of existing tools to be useful for what I want to do. So at the same time, I began wondering why some major software vendors like Adobe or Autodesk doesn't change or improve the fundamental built-in functionalities like pen tools, in spite that they added a lot of cool and modern features, such as integrating artificial general intelligences or in the field of UI UX improvement. So my interest is gradually shifted to developing way more general tools for my own works. And all of them are focusing on realizing a feature to implement the features. Even though I didn't know this concept is known as a term end user development or malleable system in the realm of HCI until recently. So this is a first example of programmable pen tools. I made it for drawing an animation that I mentioned later, but and it runs on browser, and you can implement the behavior of drawing tools, just like a basic tool or pencil or eraser in JavaScript. So by using this tool, you can also implement not only conventional tools, but also way more kind of weird or strange kinds of feeling of drawing tools, just like Dubin's Path. Or this is a drawing tool that I found when I began learning KiCad, which is a tool for designing electric circuit patterns. All these things like this. I don't know how to call it, but you might have seen in while digging in the hashtag acid graphics on Instagram. And it also influenced by one of my favorite graphic designer, David Radonick, who had provided some artworks for One Ultrix Points Neighbor. So with using this programmable pen tool, I have designed some graphics just like this or this or this. And at other time, I added a timeline and brush tool inside with using the feature of programmable pen tools and tries to make a short animation like this. This is a visual identity for International Animation Festival held in airport. That's why there's lots of airplane flying. So let's move on next. And this is another app. In this time, I tried to bring an idea of programmable drawing tool from vector-based app to raster image editing. You can implement unique brush tools by using GLSL, which is the most popular languages in GPU shaded programming. With using this, I played lots of abstract texture, just like this, or I made with using a texture created by this tool. I also designed artwork and a short video for my longtime friends, musician. And I think it's quite important to take an example of what I've made along with interacting my own tools. Anyway, and this is the last example. And in these 2 months, I've been prototyping the stop motion tool from scratch instead of hacking existing Dragonflame, as I said. in this time, I tries to make a condition to shoot programmable, even though it's not as catchy as preceding examples. And here's the live demo. So the arrow shows you have to connect at least one camera to continue shooting. And finally, I can shoot pictures like this, like this. It's very early stage of prototyping. And with using this, I've recently making a stop motion for a rock band called Tempore these days, but it didn't finish yet. Anyway, okay. So anyway, so my interest is moved from hacking existing tool to developing a malleable tool from scratch. And these days, I'm also interested in implementing a framework to developing a tool. It's kind of a higher order functionality for creative tools. So this is my main topic of my presentation, and this is the language that I've been developing for graphic design, which I call GLisp. And the look and feel looks like this. And I originally developed it nearly 3 years ago, but as I prototyped it very quickly, the code became too messy and I couldn't find it how to improve it. So for this seminar, I tried to refine the kernel and look and feel, but it didn't make it in time. So this is just a kind of a fake screenshot of what I want to make GLisp to be. And actually, this is the latest version of the GLisp. And just like a Sketch and Sketch or Para, there's features like a bidirectional editing from visual representation of graphics between code on the right pane. And with using this, you can define elements or shapes or primitives, just like pie graph or things like Blob shapes or effects means like logo. Or with using this, the graphics I inserted in at the beginning of my slide is also generated using a GLisp. Okay, so, and as for GLisp, as the name implies, GLisp is based on programming languages called Lisp, and it's kind of ancient languages. As some people say, it's the second oldest high-level language on Earth, and it is very used compared to modern languages like JS and Python, and its syntax looks like confusing as there's lots of parentheses. So some people ironically insisted that Lisp is the abbreviation of lots of irritating parentheses, just like this. So, but just in case, I'd like to introduce what the syntax of Lisp looks like. So I think the syntax is quite simple and understandable. And the rule one, all operator and function applications are prefixed and enclosed within parentheses, just like this, and just like this. And just like calling the max function in more conventional languages, but in Lisp, you need to prefix all of function name and enclosed within parentheses. And rule two, the list expression can be nested, and all of the evaluator needs to evaluate from inner expression, and each list is replaced as a computed result, and the evaluator have to continue the evaluation recursively, just like this. And in Lisp, you can also define scopes and functions just like other common languages, and just like this. But what differentiates Lisp from other common languages is that its flexibility of macro. Lisp can also take some expression as an input and output the expression, since all the expressions are nothing more than just a data type list. Just like this. And maybe this example doesn't need to be realized using a macro, though. So this nature of language is called homoiconicity, or more easily code as data or data as code. So fundamental idea of GLisp is bringing these kinds of flexibility into our daily design process by using Lisp code itself as a format of project file. As a syntax tree is quite simple and Lisp can be written in a declarative manner, it's kind of compatible to substitute things like SVG while bringing in a ability of programming. So, but to be honest, the reason I adapted the Lisp is that it's easy to implement its parser and evaluator, as I'm not a professional language designer. And also it's mysterious and looks weird syntax. And it is just like Paul Graham also loves Lisp. But in addition to my personal preferences, I think using Lisp has some advantages over other common languages. So I'm going to dive into some of the features supported in GLisp and explain why it's kind of a good choice to use Lisp as a programmable graphic design tools. So as I said, Lisp has a simple syntax and it's explicit. Its hierarchy is very explicit. So you can, from its syntax, you can imagine what the hierarchy of the syntax tree looks like, and it is also convertible to GUI representation. So in GLisp, there's three types of representation existing at the same time, and you can bidirectionally convert. Depends on what you want. But some people might think visual programming is already enough for realizing programmability for design too. But when you, maybe some people who had used the node-based app might understand that, but visual programming is sometimes very tedious tasks. So I still want to emphasize the importance of textual representation of programmable graphic design tool, as it's simply much more quicker and faster than using a mouse or drag and drop based interaction to make some deeper hierarchy of project files. So in addition to that, it is also, I think, important to annotate kind of important information, just like ranges of slider or docstrings of function, just like this. And GLisp is based on one of the Lisp dialect called Clojure, and Clojure natively supports metadata annotation syntax, and it can be attached any key value data for any types of expression. So it's just like JS doc in JavaScript or doc string in Python. So you can attach metadata for any subtree of syntax to be represented in a GUI more user-friendly, just like this. Yeah. So in addition to that, GLisp also supports user-defined viewport handles, just like this. So with using this, you can define kind of a shape primitive within project files. And this is an example for defining star-like primitives, or you can define various types of handles that cannot be seen in existing tools, or this. Yeah. It's, yeah, I don't think it's not very useful.
But it still looks magical to me.
Yeah. So with using the power of metadata, I also implemented support for inverse function for very bidirectional manipulation, just like this. And in this screenshot, deg function converts angles in degree to radians. And the rotate function only accepts radian angles. So, but when you tweak a parameter of rotate function, the parameter of deg function inversely calculated and reflected to the code, just like this. So with using power of inverse by evaluation, you can directly manipulate output graphics even if its parameter has expression or script, just like this. So I think most of programmable graphic design tool needs to be explicitly define which parameter to be promoted to as a slider or a checkbox or drop-down menu. So user and artist and designer prefers a tweakable GUI, just like this. But in GLisp, every subtree or every parameter or every literal instantly converted to GUI representation, and you can tweak it continuously, just like this. Yeah. So not only this, every fundamental features, just like basic paths or multiplication of 2 points or clamp function, can be defined with using Lisp code itself, and you can customize its behavior so to suit what you want. And in addition to this, drawing tools can be also implemented in GLisp, just like this. Also, it looks like very simple and early stage of prototyping. And app settings can also be described in Lisp, just like this. So you can define key binds or the contents of a global menu of the apps, or even batch scripting can be done in GLisp. So everything is on Lisp, just like this. So I think it's lowers the barrier to learning programming languages for designers, because they don't need to domain-specific languages, which is specialized for implementing the contents of a project file or contents of the GUI or custom user-defined widgets. So, but on the other hand, my GLISP has some issues, just like speed, performance, or poor support of graphic representation. So in this feature, I want to implement an incremental evaluation system for better performances. And I also want to try to introduce a strict typed languages model instead of just attaching metadata to make the evaluator to check whether the data type of input parameter is correct or not before evaluation. Or I want to make this language implementation as a library for being bundled in various applications, not only vector drawing apps, but also stop motion apps, or hopefully DAO. Yeah. So in the end, I want to talk about what is the difference between CST for artistic work and one for industry, even though it's just my humble opinion. And maybe you might imagine in the wild as a left side, just like UI, UX design or web apps, but I personally love things like what the heck is these things? So Kato-san wrote a paper about the issues in creativity support tools. And as I hear the word in the wild, one of the video essays come up with my head, which is called Goodbye Uncanny Valley. And in this video essay, Alan Warburton proposed the kind of landscapes of the CZI. And maybe you might have heard of Uncanny Valley, and most of the researcher in a field of CZI tries to overcome the deep abyss of the Uncanny Valley to reach the frontier of the CZI that cannot be distincted from real live footages, just like blockbuster movies. But he also showed his preferences to not a frontier, but wilderness on the side of the Uncanny Valley, and it looks like more weird and deviated and nonsenses, but he very loved these kinds of vibes. And I once tried to overcome to reach the frontier of a cool artist, but I somehow deviated my path to the more experimental scenes. So for example, there's a lot of cool graphic designers like this. So I think creativity is not kind of a problem-solving attitude, but I think creativity is more like a multimodal optimization, which has lots of answers around the latent spaces of creativity. So maybe you might imagine industrialize as a left side, but as an artist and graphic designer and music lover, I always love the vibes of indie scene or underground scene. So I personally want to emphasize that not only industrialized and industrialized and overground scenes, but also more like underground and experimental scene can be important for HCI researchers. So that's conclude my presentation. Thank you so much.
Thank you. Thank you so much.
Yeah.
So, let's start with the questions for Baku and then gradually move on to the panel discussion. There is a comment that somebody thinks this presentation is the best visualization of Lisp I have seen ever.
Thank you.
So when you start developing a new software or tool, do you have a specific image of the expressions that you want to generate with the tool? Or what is the inspiration for you to develop a new tool?
Every time I make some tools from scratch, I also come up with what the output can be looks like at the same time. So that's the case only for this tool. The case that when the tool is used by only me. So maybe I've never started my tool prototyping project without imagining how to use it by myself.
So it's always one-time thing. Like if you want to make something, you also start developing a tool while developing the visuals or the appearance of the video.
So that makes me always doesn't make it any works until the deadline. So I need to make graphic or video tools at the same time as video and graphic itself. So that's very bunch of tasks.
So I think in an ordinary or common cases, visual artists start by tweaking parameters in the existing tools or drawing something with the existing tools. But you're avoiding that somehow. Is it?
Maybe.
Or do you still do that?
I don't intentionally avoiding existing tool. So I once tried to hack or extending by using SDK or API,
but still you start with the programmable part rather than just being a user. So this seems like a kind of preference on your artistic style.
And I think there's two types of attitudes for facing existing tool. One of which is hacking. But on the other hand, there's a certain type of attitudes to using defaults intentionally or misuse it for making glitches. But my preference is towards to hacking attitude. But
so to clarify, when you say stick to the default thing, does it mean like just producing something that looks really default?
Yeah, it literally defaults. Just like displaying a gizmo of a 3D software or intentionally using a Times New Roman points.
So you think they are close to your kind of attitude?
Maybe
kind of closer community of people.
Maybe recent mood of the internet art or media art was to using default by hacking or criticizing existing.
So it's already criticizing it by using the default values. Interesting.
Well, now I'm trying to making a tool from scratch rather than hacking it.
I see. So you have more motivation in expanding your expressions with your tool or providing. Okay, so the question is whether you want to make the tool for yourself or providing the tools or framework to others. Right now, which is your interest?
The first priority is only for my own work, but hopefully every creative tool should be open sourced so that every artist can be modify its behavior from a lower level, just like craftsman in 19th centuries. They toolsmithed their own tool by themselves for their preferences, but now we only have choices to using ready-made software. So maybe for now I make these tools only for myself, but someday I want to make it everything open source, just like a Blender.
Thank you. Xavier, do you have particular questions for Baku?
Yeah, I had a question. I was really impressed by the GUI generation for your Lisp part, your GLisp. And it reminded me of the tool that I showed, Sketch and Sketch. Using Sketch and Sketch, I remember that I had a lot of frustrations because Sketch and Sketch tried to give you all the handles to manipulate your image all over the place. It gets very busy as soon as you start having a lot of shapes on screen. And so I was wondering if that was a problem with your tool. And how do you manage complexity when you can edit everything through the visual interface?
Yeah. To be honest, I have never heard of Sketch and Sketch until Kato-san taught me about the preceding researches in the context of HCI. But as for the handles, I'm still struggling with how to resolve the complexity when you edit project file more complex.
But to my understanding, in GLisp, I think you're limiting the number of widgets being populated at the same time by allowing the user to only focus on one single object, right?
Yeah.
So I think that will kind of limit the list of the parameters, right? So I think it's already somehow limiting making it manageable, I guess.
Yeah, I see.
Okay, so let's move on to the panel discussion. じゃあ、画面共有していいですか？すみません。自分が消せるんだ。僕、since I am the organizer, I can forcibly stop the screen sharing by others. So right now, we have heard all these excellent presentations by 3 invited speakers. And now we are moving on to the panel discussion, which is really a kind of open-ended discussion, I guess. I think I can immediately move on to the Google Docs, but I guess
may I know the URL?
It's in the chat.
Yes, if you look into the chat, that will navigate you through the Google Docs.
Thank you so much.
I think I can start the panel discussion by benefiting from the fact that I am sharing the screen. So I think the upper figure was previously shared by Baku. And this is the dissertation by Nolan Molded. And she kind of poses the question that, this kind of tool palette design has been suffered from the stagnation. But is it because the designer's tools are a solved problem? If it's fixed and if it doesn't change for a long time, it might mean
because
it's done.
good too.
Yeah, it's good enough for the artist. So obviously this is a kind of good question, but she quickly refused that. Designing software is an open issue because part of a designer's work is to choose and question their tools. And the second, and probably more important reason, is an emergent reappropriation movement coming from designers themselves, following they are starting to learn programming languages. So, it's interesting that in the 1960s or 70s, the users of computers are all programmers, so they knew how to use programming languages. And as Tomoya-san showed, they were designing tools and programming the tools by themselves somehow, I guess.
I think some part of sound programming was from its beginning, really it's divided its division level. But early experiment of the sound programming was really interesting because the programmer was using the speaker as for just hearing the binary signal in the computer for the debugging, and it eventually turned into the earliest experiment of the computer music.
Oh,
yeah. So it started kind of the misuse of the tool, like debug speaker for the debugging, but mostly if we search about the history of the computer music, the very first tool was that I showed in the presentation, Music System by Max Matthews. But why that the earlier experiment was not counted into the musical practice is that is the interesting question for me, because music was the very first system that invited the composer to collaborate with the engineer, so that the music makes kind of the composer didn't need to know about the deeper part of the computer. So that the division of the labor made the system as the first computer music system.
I see. Probably related to that, it seems like all of today's talks focus on somehow data as code, or code as data. And, every talk discussed how we can represent music as a code or represent visuals as code. Whereas, our initial motivation seemed to be, rather than making this data structure, we wanted to make some tools that are composable, as Xavier said in his presentation. He mentioned that these tools should be more composable, and if that is kind of ultimate goal, why do we need to struggle with all these programming language issues, right? We want something composable, and we don't necessarily need to stick to the programming language design or programming environment design. But what brought you to this field? Like, why did you want to make this like from scratch rather than hacking the existing tools? So probably Xavier, could you start?
For me, I think it's definitely a bias from the fact that I'm a software engineer and I like to code. So I think originally I ended up there because I was using DAWs and I was like, well, I wish I could do these things by programming, but just like hacking on the existing tools is too limiting, because it's really not thought to be like, it's this idea of hackability is not built into those tools. And I think that's what I was missing and wanted to bring there.
And then you rather avoided customizing the OSS, but rather build it from scratch. And is it because open source software are not accessible enough, or?
I think it's mostly because a software like Ardor, for example, is really based on the principles that are used by all those more traditional DAWs.
GUI applications.
Basically, it's difficult to repurpose one of those and make it hackable and programmable and malleable. I found it easier to start from scratch and experiment, and it makes it easier to iterate on this.
So how about you?
Yeah, Ardor is I think it's the only one choice of the OSS software, I think so. And its source code base is really huge. And it is not, it is open, but not modifiable.
And the purpose of making it composable cannot be achieved by simply providing the extensions to those.
Yes, Arduino actually have Lua API. It's the API is embedded and the programming language is embedded, but it can automate something because, for example, you can select the many operations from menu. You can automate this by Lua scripting, and maybe some data of the track and region can be automatically converted in some data, but it's an imperative process and like a batch process of the.
So it's more like automation support rather than
custom
exploration support.
Yes.
Yeah.
See, interesting. So Baku-san, why building a system rather than hacking? You mentioned that you hack some software.
Yeah.
Like Google Maps is one case of hacking the Google Maps. Right?
Yeah. Even though I use some existing library to fetching a series of Google Street View imagery, but it's kind of a hacking.
Yeah.
But you're asking why I.
Yeah, why or when you start to build a new program environment?
Why did you start the comma application? But before that, you were using the Dragon frame for the Komadori stop motion animation.
This is simply because I once tried to using its built-in API to send some OSA commands to attaching some tasks in an external application, but it didn't simply enough for what I want to do in the next. And as I personally cooperated the localization of the apps, Dragon Flame, so it might be able for the developers, but I somehow want to make it from scratch. But basically, I don't like to just following trendy or popular looks and feels, and I rather like experimenting or intentionally misusing tools. But existing tool doesn't even allow me to misuse it or deviate from its original purposes. That's why I had only one choice to make existing tool, rather developing the tool rather than using it. Just like Matsuura-san.
Misuse of the tool sometimes become kind of mean or paternalized, like glitch. Initially glitch started as a destructive process of data, but it now
common way,
and sold as a plugin.
It's interesting. So another kind of observation that I had today is all of us are developing new tools for artistic work, but we don't necessarily want to be too experimental. I mean, for example, for music, there are live coders who make kind of experimental music by writing code, and there are noise music, and I don't mean that it's not a good music, but I'm just saying that we can easily be experimental. Like we can make something that look really weird, and we can make something that is really a kind of outlier in the current artistic practice. But to me, it seems like we're somehow balancing between being weird versus being a kind of person who want to make something that might become popular. Like, it's not like making something completely new, but rather we stick to the current artistic context. We stick to the context, but then we are trying to push that frontier a bit forward rather than making a detour or going somewhere else. Is my observation correct, or do you have any thoughts on this in artistic practice versus your style of making tools? Probably Xavier could start.
I mean, I think for me, it's maybe a limiting factor is just my imagination on this. It's way easier to start from something that I know very well and that I'm familiar with, that I like and that I want to expand upon. And because otherwise I just don't know where to start. And then once I start working on this, then I develop an intuition of like, what could be interesting, weird things to do with it or new directions that I could take. But I need to be grounded somewhere.
Oh,
that
I
makes
see.
sense.
Interesting. Yeah.
I have ambivalent feelings because I have never been completed my musical work with my music languages that you have. And I think the experimental or not, we don't need to consider, at least when we are designing tool, because the experimental or not is always evaluated with the comparison, the relative, it's
or by the audiences or kind of culture or where the
both,
content is?
both, and it's over time. Maybe it is just thought as experimental from the view of the future. And I think the problem happens if someone want to make the specific expression, but it was really difficult than the other expression. This kind of the imbalance of the sometimes political or economic imbalance of the expression, that becomes problem. And the outcome expression is experimental or not is, I think it's the out of scope of discussion, I think.
I see. I see your point. Like what we see as a problem is that the current tool landscape is really limited in a sense that it's either open source but not hackable, or made by a profitable company and limits the composability. And we want to change the landscape somehow, which will empower the artists
and
globally.
Sometimes experimental expression that comes from the imbalance of the tools, because like a glitch expression or the hacking of tools, these experimental expression should be considered as a good outcome, but the existence of these kind of the big tech tool or something should be considered as good, because they produce the as a side effect of the
anti-profitable company enabled this somehow. Baku-san, do you have it?
As for experimentalism, maybe I personally don't think what I'm doing or what I showed in this presentation is experimental. I just wanted to avoid imitating pre-existing media or styles. So just like most of the drawing apps in iPad tries to imitate the feeling of the
brushes
or
presets,
oil painting or whatever. But I think every technique or every media has its own feeling or texture inside its nature,
built into the tool.
So I want to just extract this feeling of the.
So you want to be free from the existing textures that these tools have.
So maybe using computer might be in metamedia or that can transform into various kinds of tools. But most of the case, they only just tries to imitate the pre-existing analog tools or other tools. But I want to just make explore
new kinds of feelings.
So in this perspective, I don't need to distinct experimentation or not the experimentation. There's only not imitating or imitating.
So I think in Baku-san's case, he's really focusing on finding kind of goodness. You mentioned goodness function sometimes,
yeah,
right?
yeah,
And
yeah.
so you want to make something really good, which is kind of, I think it's your judge whether it's good or not ultimately. And it's not whether it's experimental or not, which is judged by the other audiences. And so to me, it seems like solving a very difficult problem where we can easily go to somewhere which has a kind of low goodness value and say that it's experimental. But I think Baku-san's case, he's really exploring a good position in his kind of visionary landscape, and then building a tool to go to that that mountaintop of the goodness function by himself. So it's pretty much like designing the landscape by himself and then building a tool to go up onto that landscape. So that's why I really respect what he's doing, and I think it's some sort of kind of shared tendency between us. Like we have our own judgment on the goodness, and then we are kind of going there. But rather than using existing tools, we are making new tools because there is no existing good ways to go there. It's really kind of interesting thing that I found. Well, actually, there are many things to cover that we want to cover, but the time is actually already over. But Xavier, do you have timing constraint?
No.
Okay. How about us? Okay. So we will extend a bit because there are so many interesting topics to cover. Okay. Let's see. So I think it's related to the question of why we are designing programming language from scratch. But what is the pros and cons of defining kernels in creatively supported tools, like kernels, which means primitives, language primitives? Like existing DAOs is a kind of combination of predefined primitives, whereas the programmable tools might have lower level primitives, and it's easier to compose these things into functional tools. What is the pros and cons of these two different approaches? Like one is kind of big company or open source project defines a kind of primitives in a higher level versus us or programmable tools defining the primitives from lower level. Do you have any point to start? So the comment in the doc says that these kind of primitives really lowers the threshold for novice artists to just jump into the field, because these higher level primitives often allow them to kind of make something that look or sound good, which motivates them to start, and they start to learn by these good primitives, right?
Yeah.
Sorry.
Okay. I personally think that there's a major problem here in this design space, and it's something that I think about a lot. And it's what I said when I said that it was difficult to automate things like adding a track in PA because it's based on a programming language. It's those lower level primitives make it really sometimes difficult to do simpler tasks that like really increase the entry, the barrier entry into using those tools. And I think it's a fundamental problem of this design space that I don't really have a good solution to right now. But I think like being able to compose things and then slap an interface on top of them that might be simple could be an approach to this. But yeah, I'm not sure.
I guess that's related to something called a lot of abstractions, or we can design a kind of multiple levels of the user interfaces. Like the most abstract interface as a programming language, whereas the most higher level kind of thing as the GUI, and kind of making this ladder a more, I don't know, more. There could be more steps than the current programmable versus the existing thing. Yeah.
Absolutely.
As for multi-level abstraction, I personally think the notion of orthogonality can be useful. Just like for my example, GList can be used in office works, just like defining a pie chart or some other graphics or flow chart primitives as a preset. But for the people who wanted to customize its behavior from lower level, they can explode the component into much more smaller primitives and change the behavior of it. So
I think what you're saying is that the GList is by its design, it's essentially a kind of abstract syntax tree, and you can kind of freeze, evaluate the function and make it like it's pretty much like rasterizing the image, right? And then make it tangible, editable. But then you cannot reverse this function, this operation, because it's a rasterization, and you cannot kind of abstract things from there.
Or maybe most of the built-in primitives, just like an ellipse or a circle, as I showed in the demo, is already defined by combining visit-to primitives. And visit-to primitives is also defined as a combination of SVG's D attribute. So you can choose the appropriate level.
Appropriate level to start. And then go upwards or downwards, which is the user's choice.
So maybe novice might prefer much more higher level of manipulation, but they can progressively get used to the languages or flexibility of by using programming, or maybe it can be textual code editing, but it also can be done via GUI completely. It doesn't matter, but it's progressive programmability is important.
Progressive is kind of a good way to say it, I think.
The one thing I learned from my language design, I designed mimium as the possible as have the lower primitive. It doesn't have a sine wave, even sine wave oscillator. Just it has the basic arithmetic sine cosine function. But so in the existing languages, there's a kind of the layer of division that uses the programming language that develops the primitive object of the language by C languages, and there's many kind of the steps. For example, developing C languages was designed assembly, and there's the kind of the steps. But lowering these primitives into general level, they are always, but even though there's always the maintenance of this primitive language, and by lowering and lowering the primitive, there are more single deep division of labor that users of the language, right? For example, the jurist, the user of the jurist, but still there's some kind of the primitive development of the jurist environment itself. So who becomes the future maintainer of the jurist become problem, I think. Right?
Maybe one of the good point of adopting Lisp languages as host is that using it and implementing its evaluator is nearly equal skill sets. Maybe
in the case of sound, especially sound, it becomes difficult to maintain the lower level language because it has a very hardware specific problem or OS specific problem like the scheduler or the memory allocation. So yeah, maybe because of that, the sound is the special case.
Xavier, do you want to say something? No?
Yeah, I do think that graphics has the same issue. It's just that we're used to dealing with higher level graphic primitives. But Baku, you mentioned earlier that you also work directly with GLSL, and I was wondering, would you see that as an thing that you could easily do also with GLisp? Like working with very low level graphic primitives?
Right.
Generally, you're using SVG as the baseline.
Ah, yeah,
But
yeah.
what about
Yeah.
GLSL and other?
Or maybe my concept of GIS can be applied to any other fields. So
But then you need
I
to
can-
design a new, different tool based on the same idea,
yeah.
and then evolve it somehow.
So maybe I might can use GLisp for compiling chunks of GLSL code to compose plus tools without seeing GLSL code itself. So I think GLisp can be embed languages just like a Lua for any other softwares. But in that case, someone needs to prepare the basic or fundamental definition of the primitives, just like unit generator or GLSL function or any other.
So I think more fundamental question here is, so let's say we have Adobe tools, and Adobe tools is the same for everybody, right? If you download Adobe Creative Cloud, the tool is the same for everybody, and you can, for example, share the settings for each tools, and so it's really relatively easy to communicate with others who use the same tool. But if we are making this kind of composable tools, and if everybody has his or her own tools within his computer, probably the collaborations could be a bit difficult or challenging. Have you heard of this? Have you thought of this kind of collaborative aspect of art making?
I don't need to. I don't need that to
Collaborate.
every artist to be collaborate in terms of sharing its project files or user settings. I think it's rather like replaceable. It's just means replaceable. So maybe so designers in a startup company needs to be easily replaceable as they quickly move to.
Now I think it's related to the division of labor, and because the labor is standardized, every artist can be replaced with other artists or the design. That's your observation.
So in that meaning, I don't need to the tools to be standardized or normalized. So maybe
I haven't thought of that.
in the music, various kinds of musicians can collaborate, even if they don't know someone other collaborators instruments or what they're doing. They can collaborate.
Yeah, that's an interesting observation, because you mentioned that musicians can collaborate with their own equipment, right? Somebody uses drums and somebody uses a guitar and that kind of thing, right? And they have the common language of music or sound as the language to collaborate. Okay, I haven't thought of that.
But basically, like if you want to collaborate in this way, you need to have a common protocol that everybody's following. In the context of, for example, jazz music, there are codes that jazz musicians follow in order to be able to play together. And I think for those tools, it's probably a little bit the same. It's like you kind of need to establish maybe APIs or like libraries that are generic enough for like interfaces that people are going to reuse and recombine in different ways, but that can still interoperate in some ways, if that makes sense.
I see. So probably we can make our own tools by ourselves. There could be some sort of glues between these tools, which is currently out of scope of our tool design, or is it already in your scope?
Protocol designs are also a big problem.
Oh,
Yeah,
MIDI is one of the protocols.
yeah,
Is it?
but I think problematic protocol, I think.
Yeah, and in the case of jazz music, jazz is a genre of music, right? And it already somehow limits the expressivity by saying that jazz is kind of standard and there is rules for this music, right? So is it the question that we want to find a kind of good balance between these kind of generalizable expressions versus some sort of specific artistic styles, or I'm not sure. I'm actually not sure what I am saying.
I think it's a very interesting fundamental question when you're working on tools like this, of like, what is a good balance when I'm making the primitives of a tool between something that is expressive and generalizable, but also having trouble expressing what I mean, but like, yeah, a good balance between something that will work for different purposes, but is also low level enough, high level enough to, yeah. Sorry, I'm having trouble crystallizing that thought.
We're all having troubles with this kind of abstract and difficult problem. I think it's a kind of open question right now. So I think we can go a bit toward a societal side of this problem, which is how do we fund research or fund development into these fringe tools for artists? Like, there are artists who prefer minority tools, but it's really difficult to maintain the tools or continue developing tools. And I think it's a problem of ourselves, right? I mean, we want to make some new tools and we want to fund ourselves because for living. But obviously Adobe or these kind of profitable companies pay you better if you get hired by these companies and build tools that are standardized. What do you think of this current landscape?
Maybe you once interned at Adobe, right?
Yes. I personally have an experience of working at Adobe, and there I was prototyping a tool for a new product, and so there was kind of specific goal for that, and I was kind of doing research to prototype the tool, but I think there is no difference between me doing research out of Adobe or me doing research in a current research institution, because at Adobe, although I was bound to a specific project, it was interesting enough because there were lots of open questions of how to design new tools, and it's the same for Adobe. And I heard that, in Adobe, those prototypes do not go live, do not go outside of the laboratory because it doesn't make any profit. And I think that is a kind of problem, right? From the researcher's perspective, it's the same because if they can publish papers, it's done. So even for Adobe researchers, they can publish their papers, and then I think their reputation as a researcher is safe, right? As long as they can publish at prestigious conferences like SIGGRAPH or CHI. But the problem here is there are many good researchers at Adobe. I know many of them, and they are making new tools, and they're really cool. But because of the size of the company, they cannot, for example, publish their outcome as a product because maintenance is really expensive. And startup companies or small-scale startups are or research labs better in this perspective, like publishing new product as an open source project, for example. So I'm not sure. I'm kind of in between these two different cases, I guess.
I think this is kind of the first stage of the problem around the sustainability of this kind of creative support tool, because most of the sound programming language, just except for cycling Max or Superflighter, the 90% of the sound programming language is developed and maintained by the original author. So I sometimes imagine what happens the 50 years in the future, 50 years, the original author already dead. So
yeah, I think there are several problems happening these days. Like I think processing foundation suffered from some sort of funding issues these days, right? The processing foundation, and also this year, Unity and Unreal engines both suffered from criticisms from the developers. Like they changed the business plans or that kind of thing, and yeah, so it's a tough problem, I guess. So from my experience, I feel like so I have a hope because there are people like Xavier and Lambein and Tomoya, because we are all young enough to live for the next, I don't know, several decades, and there are more to come, I guess. I mean, in the 1990s, artists didn't know how to write programs, for example. But these days, programming education is kind of duties for primary school students, and they know how to write code somehow. And when this programming ability becomes kind of commodity, there are more and more needs for this. I mean, they are aware of this freedom, right? So they know that there are some sort of interesting areas that they can benefit from. And so, I mean, it's not a kind of technical answer, but time solves somehow, in a sense that there are more artists who can write their own programs and artists who can develop their own tools. And that's where I want to contribute as an HCI researcher. Like, I was really surprised that you mentioned that you're going to providing a framework for the developers, right? And I think that's something that we as a researcher needs to do, rather than, I mean, it's also important to make some concrete tools, but it's also important to kind of abstract this knowledge of tool making, because then there are more people who can benefit from this knowledge and make new tools, even though I am dead, for example.
Also enough young.
Yeah, I hope so, but yeah. Yeah, something to say about this.
Anyway,
yeah.
I personally don't think the sustainability or the sustainability of the single software is important, because as I from my experience that I prototype the graphic design tool or stop motion tool from scratch within 3 months, it is kind of not so hard to some software which is enough for using by the developer themselves. So I don't think all of the artist developed tools needs to be commons, just like Adobe or 3ds Max. It can be one-time software. So but what I want to do is providing a framework for making a one-time application by the artist themselves.
Yeah, I think Baku-san mentioned in the previous presentations that he's trying to making the ways of making, right? And I think that's part of this, framework design, I guess, because we want to provide knowledge to the artists on how to make their own tools, but not necessarily everybody needs to make them tool, or
not only knowledges, but also the concrete library for building their own app, design apps can be useful. So I've been developing a UI library, component library in Vue.js, which is especially specialized for making design tools, just like a slider or a color picker or angle knobs. It doesn't commonly seen in well-known library, just like material UI or something. So I've been also trying to making some
primitive
useful
building blocks
for making the tools. It's a kind of a nested.
Yeah. Let's see.
But despite that, there's needs to some people needs to be the frameworks of the toolsmithing itself. So the sustainability issue can be remain.
Yeah. I see.
Yeah.
So there is a question regarding the contrast between creative mode versus problem-solving mode when using our programmable tools, because I think the initial motivation is to enable more exploration during making something, and that's why we have designed these programmable tools. But it is often the case that the problem-solving mode, or like operating on GUI widgets blindly would actually help us kind of come up with the new ideas, or so it's not always a bad thing to manually manipulate things. So how do you do you intentionally switch between this creative mode versus problem-solving mode during your artist making?
I only have a creativity mode.
That's really good.
Maybe it's the same meaning, but I think I might say I have only problem-solving mode. So I rarely compose the music with the DAW software, and 80% of the operation, what I'm doing, just doing thing is the writing the curve of the parameter in the timeline. And that is because the part of the what I started making the programming language, because it is really irritative. But when I'm making music with DAW, I couldn't split the process of the pre-production and post-production. So I always starting the mixing and mastering while I'm composing the music. So that is so in some views, that is for me, it's the problem solving always. But it's kind of there's no distinction for me between the creative mode and the problem solving mode.
Or people who wants to who need a good tool for problem solving mode, they can use lots of existing tools, just like Figma or whatever. So as for the creativity mode, or DIY tools can be useful. So that's a kind of a two different part of a industry or community.
See, actually, I see this contrast very interesting, but at the same time, I feel like, Xavier, do you have any thoughts on this?
Yeah, I guess I think for me, like what problem-solving mode means is when I'm kind of, in a sense, fighting the tool that I'm using.
Compiler design is just pain mode for me.
Yeah, but even like if I'm using PAR to make music, I'll be like, oh, I have an idea of something that I want to make, and then I start making it, and I'm like, oh, nothing works. And and this really like sidetracks me from the creative process. I mean, you could say that like making this tool itself was me getting sidetracked from my creative process. And it's kind of a conflict for me of like, when do I, how do I switch between the two and reconcile them?
So it seems like it's not a bad thing that these two modes kind of exist in the whole creative process, and both benefits as to the final outcome.
Yes, I guess creative mode is the mode that I always want to be in, and problem solving mode is the mode that I have to be in sometimes. Because,
Yeah,
I see. I see.
Okay. There's the reality of things.
I guess Baku-san is also in both modes, actually.
I think I misunderstand the problem-solving mode as a timing of use of the tool rather than developing the tool. But as for developing tool, I also have a problem-solving mode.
Yeah. I see.
And I'm still struggling with how to implement this. Yeah.
Right. I see. Okay, so we are actually extending the seminar by 30 minutes by now. I think we have touched on many interesting topics here. Do any of you have any topics that you want to touch? So anyway, we have this Google Docs, and I think we all have access to this docs. So for the questions that are not answered in the previous sessions, I think the presenters can comment on the questions later. And the only thing that we need to do right now is to touch on any missing topics that can only be discussed with all of us here.
Maybe I'd like to suggest some topics that most of non-programmers misunderstand using a programming language along with their design process is only for automation or improving efficiency. But I personally think that it can also be useful for altering the fundamental nature of lots of repeating manual processes. So I'd like to tell people that the programming is also useful for
manual tedious
people who prefers manual processes.
I see.
So in that meaning, how about your tool or Xavier's tool? Is that oriented to empowering the manual processes?
I think so. I hope so, but it's still early stage. Yeah, but one important thing I now develop in the part of my development is turning every data into the function. So one thing I didn't mention this today's presentation is that in the music field, there's no direct manipulation. The manipulation of the object of the manipulation is the generator or the instrument. So we are always controlling the function. If it is if it was a normal DAO software, so
so I think Baku-san assumes that there are the contrast between programmable, like generative artwork that can be easily generated by code versus these kind of handcrafted data that can only be like generated by the handmade manual operations. But in the case of music, I guess they so. In the case of computer-based music, I think it's always it always starts from the sine wave or some sort of kind of data structure. But in the case of physical equipment, it produces some sort of sound. How do you relate that to the current DAO or POW kind of landscape?
Is that oriented to kind of enhancing a concept of a modular synthesizer, or is it oriented to making new types of instrument that musician can easily touch or interact with it, and they can manually play with it?
I think the focus is a little bit different from the kind of personal instrument making, because it always realized by Max or existing sound programming environment, I think. So what I'm doing now is the kind of challenge that can we consider as the stream of can we consider the function as a data, but can we take that concept part into the musical creation process really? Because even the modular synthesizer cannot send the modular synthesizer itself. So it is not the recursive or the computational process. But current existing sound programming environment is just at best the simulation of the modular synthesizer. Some of the experimental languages uses have the visual programming data flow workflow, but imagine that there's a lambda object and it can take the function as a data. Is that really meaningful or not?
Yeah, it seems like Tomoya-san is exploring kind of fundamental substrate, which is a term used by some people in the malleable software people. They want to find a kind of good substrate for representing something, and in your case, it's music.
Yes.
So that's really, in some sense, highly research-oriented, whereas Baku-san's approach is more like, as a visual artist, leveraging the benefits of programmable tools within his own existing artistic workflow, and so he wants to kind of emphasize these benefits of programming as part of the artistic workflow, not only for researchers or tool makers like us, but for kind of broader audiences of artists who might potentially benefit from these programmable things, and make it as part of their kind of repetitive,
or
so,
tedious,
tedious thing that could also happen in programming activities, and that's a good thing to kind of look for good the mountaintop of the goodness function.
So I think programmable design and computational or generative or parametric design is different things. I think programmable design is broader meaning that also contains automated, but also contains manual and repetitive processes, as I said. So I want to emphasize the benefit of introducing a programmability into the tool for just like a painter or whoever.
Interesting. So I think it comes back to the original statement that Xavier said in his presentation, that the composability is the important thing, right? So when we make the tools for artwork composable, that actually benefits not only for those who want to save time by by making programs around the repetitive tasks, but also for those who want to do these manual labors. It's kind of higher level concept, which is to achieve the high composability and probably the malleability within these tools. So Xavier, would you provide some comments on the discussion on this?
Oh, yeah, I'm having a hard time crystallizing the things in my brain. Yeah, I'm sorry, I don't really have a good thing to provide you right now.
No mind. So I think we're a good time.
Yeah.
So I really want to appreciate all of you giving the excellent talks and having this fruitful discussions. And I think we can continue the discussion online or offline, I guess. I mean, we definitely have shared interest in this domain. And I'd love to see what you're going to do next. So let's see. I think I want to conclude this edition of the seminar, and I want to share the screen, but I don't see the share button somehow. I don't know, but my left half of the screen is frozen, and I don't see the sharing button. So I think I can just stick to speaking out here. So thank you for all the audiences who remain online for late. I think I hope you have a good time listening to all these interesting discussions. And so this is the fifth edition of the seminar. And actually there will be a sixth edition in November, next month. No, December next month. And on December 13th, we will invite Jennifer Jacobs. She will come to Japan physically this time. Really? And also we will invite Koya Narumi, who is an AC researcher, and they kind of share the interest of building a kind of physical creativity support tools, like the 3D printer for ceramic artists, in the case of Jennifer. And she's also known for her programmable tools on visual artist side. So I'm really looking forward to the sixth edition too. And so yeah, thank you all for coming to this seminar, and looking forward to seeing you in the next edition. So thank you.
Thank you so much.
Thank you, Jun, for organizing this.
Yeah, thank you so much.